Welcome to another episode of Python for the Mindstorms Robot Inventor set. Today we're going to talk about maths. Oh, you're still here? Oh, I just assumed that everybody would have left after I mentioned maths, but I'm glad you're sticking around because maths is actually super fun in Python. And once you get your head around it, then it's going to make your life a whole lot easier. And I promise we're going to work with our robot as well. So we're going to make sure we improve our code from last lesson using our new maths knowledge. Okay, so before we get started, let's go into Mindstorms, okay? So this is the code that we left off with last lesson when we were doing our gyro turn, using the sensor, using the yaw sensor on the gyro. But we are going to create a new project so that we can play with our mathematics here. So let's click on the plus sign, create a new project, and then make sure you click on the Python button. Let's click create. So over here you'll see that at the start of our code it says to import math. So there in Python there are a lot of inbuilt math functions. It's already quite fully fledged, but it also has a lot of additional functionality by using that import math method. For example, you'll be able to work out a lot of trigonometry functions and a lot of data manipulation sort of functions as well. We're not going to go too deep into it. We're going to keep this fun and just to make it so that you can have fun with maths in Mindstorms. Okay, so let's look at our basics. Let's start with x equals 5 and y equals 6. Okay. Let's save this project. Save it as ca underscore python underscore math. All right, so we have x equals 5, y equals 6. So this is these are two objects that we just created. One, they're both equal to a number. This is a very special kind of number called a integer. Okay, so I'll just put a comment out. An integer or int is a whole number. Okay, it could be a positive or a negative number, and it is a whole number. And later on, we're going to talk about data types as well, and why we have the separation of different types of numbers and also different types of text. As you may have noticed in the last few episodes, some of the things that we type into Python, we don't put any brackets around or quotation marks around it. Things like numbers, we don't put quotation marks around it. But sometimes we put quotation marks around words like strings, and there's a whole bunch of reasons for that. But we'll go through that eventually. And usually when people learn Python, that's the first thing that they go through. But we're going to go through it last because we want to do all the fun stuff first. So let's have a look at our thing here. So x equals 5, y equals 6. So what can we do with these functions with maths? Well, we can go here. We can go print x plus y. So this is going to just simply add 5 and 6 together. So it should print out the number 11 inside this area here. So when you know this area where we see all the Python errors from our past lessons, well, it's also useful for printing information out so that we don't have to wait for it to type along the screen of our robot. We can actually print it out over here so that it runs a lot faster. So let's connect our robot. Turn it on first. Okay, so we've connected our robot. Now, just behind me is the play button. So if I'm blocking it, then that's why that's here. So I'm going to press the play button. Makes a beep, and then you see here on the screen, it's printed out 11. So the print method is very useful for printing things out quickly so that we don't have to read it on the screen of the Mindstorms hub each time. Okay, so this is addition. What about subtraction? X minus y. Subtraction. So if I press the play button again, over here, it's printed two things. The first thing is the addition part, where it's 5 plus 6, and then the next part is 5 minus 6, which is -1. So once you get really used to using maths in Python, you'll find that all your other calculators, like the phone calculator or scientific calculator, just completely inadequate, because the calculator in Python is so much easier to understand. You can set variables, you can do operations in different orders, and you can just do so many more things in Python. So it's really quite cool. What else can we do? So we've talked about multiplication and division before. So here, we got print. Multiplication is Shift 8, which is the star key. This is multiplication. And then print X/Y. This is division. Okay. So if I run the play button again, it's going to print all these out. So it's 5 plus 6, 5 minus 6, 5 multiplied by 6, and 5 divided by 6. Okay, so we press the play button. See? So 5 plus 6, 5 minus 6, 5 multiplied by 6 is 30, 5 divided by 6 is 0.83 repeater. Okay? So in Python, there is another really important operation, a fifth operation we call modulus. Okay, so modulus is represented by the percent symbol. Okay, and a modulus is exactly the same as the first number divided by the second number, but instead of throwing out the normal answer, it just spits out the remainder. Okay, so 5 divided by 6. Usually 6 can't go into 5, right? So 6 goes into 5 0 times. Okay. But what is the remainder? The remainder is 5. So 5 modulus 6 is equal to 5. Okay, and then I'll show you some other cool tricks with modulus as well later on. So print modulus y. So this first number divided by the second number, and it returns the remainder. Okay, so let's press play button. You can see here 6 goes into 5 0 times, but then there's 5 remainder, so it's 5. So let's try some different numbers. So how about we go 15 divided by 6, 15 for x, and then 6 for y. Okay? So if we look just at the modulus operator, then it is 15 modulus 6, and that will equal 3. Okay? Why does it equal 3? It's because 6 goes into 15 twice, and then it returns the remainder, okay, which is 3. So 15 modulus 6 is equal to 3. Okay. Okay. So what if 6 goes completely into x? Okay, so if we change x to 12, and then we run the modulus 6, then it will return the remainder, which is 0, because 6 goes completely into 12. So we press play again. See? Now, modulus is really useful for programming because it helps you check if something is divisible by something else. Okay? So if you wanted to check if something is a multiple of 17, is like the 17 go into this number cleanly or not, then all you have to do is you use whatever your number is, modulus 17, and then see if the answer is equal to 0. Okay, so that's why modulus is so powerful, and it's so useful as well. So if we have another math problem, let's say you had a problem in maths come up, and it says let's make it a really simple one so that we can understand it. Okay, so let's say make x equal 23. How do I know if x is a multiple of 7? How do I know if x is a multiple of 7? Well, obviously we know that x is not a multiple of 7 because we know our 7 times tables. But imagine if this was a really big number, right? If it was a really big and confusing number, we might not be able to know off the top of our heads. So all we'd have to do is we would go something like x equals 23. And then we'll go print x modulus 7. And then if that comes out as anything other than 0, then it's going to not be a multiple of 7. And then we can take that a bit further. We can say if x modulus 7 doesn't equal, let's say it equals 0, then we print x is a multiple of 7. Else, print x is not a multiple of 7. Okay, so now we can get rid of this one because we've created a little bit of some logic to check if x is a multiple of 7 or not. So if we press play, see, it says x is not a multiple of 7. Okay, so if I change the number to 210, then it does become a multiple of 7. So I press play again. Let's come up here. X is a multiple of 7. So that's pretty cool. What else can we do with maths? It's so we've just learned how to add something, divide, multiply, and subtract. We've learned about modulus, which is really, really important. But now let's look at some math library functions, which is what we have imported up the top there. That says import math. Let's look at how we can use those functions. So here, we can also go like this. Math.ceil 6.6. Okay. And then we'll print that out. So what is ceil? So ceil stands for ceiling. It rounds the number up to the nearest whole number. Okay? So ceiling represents rounding a number up. Okay? So if it's 6.6, then it's going to round the number to 7. So when we print, the last thing that you're going to see print is going to be the number 7. So let's press play. 7, see? And then the opposite of that is print math.floor. And then if I put 6.6 in there again, it's actually going to print out the number 6. Okay? So floor stands for floor. It rounds the number down to the nearest whole number. Okay, so the first number it prints out for 6.6 ceiling is going to be 7, but then the second number it prints out is 6.6 floor, which is going to be 6. So we press play. Okay. So imagine if you were doing a program or playing or creating a video game or something like that, and you have these numbers that you want to round to certain values. Like you don't want to have, like for example, if you had, how would I say? If you had a farm and then you had 268 chickens or something like that, and you wanted to round it up or down to the nearest 10 chickens, so that it's more or less a neater number, then we would use something like math floor to round it down to the nearest decimal. But if I want to round something like 268 to the nearest 10, then it's not a decimal, isn't it? So we use something like math floor, but we need to know how to use it. Okay, so right now math floor we know rounds a decimal number to the nearest whole number. But if I wanted to round a whole number to another whole number, then we'll need to be smart with how we manipulate it. So let's have a look at this. So let x be equal to 268. Round it down to the nearest 10. Okay? So the answer should equal 260. Okay? So I'm trying to round x down to 260. So how do I do that? So x equals 268, right? But math floor only works to decimals. So all I would have to do is do something like this. Is go x divided by 10, right? And then we would go, and then we would turn that into a floor. So go math.floor x divided by 10. All right, and then multiply it by 10 again, because first we turn it, we go x divided by 10, which turns it into 26.8. So now it is a decimal. Then we go math floor around that, so we'll go to 26, right? Because we're rounding it down to the nearest whole number. But then we re-multiply it by 10 because our whole number started out 10 times bigger. So if I print this out now, print math.floor x divided by 10 and then multiplying it by 10 again, then that will round 268 to the nearest 10, right? Round it down to the nearest 10. So let's press play. See, 260. So this is just an example of how you can use really cool functions with math to do your homework for you, essentially. But remember, I did promise you that we were going to upgrade our code from last week, okay, using our newfound knowledge of maths. Okay, so let's have a look at the code we did last week. Okay, here we are. So we have a function here, the right turn and then the custom angle turn. And there's a big problem with this function. It's that when we are running this function, it has to be a right angle turn, right? And that's not exactly what we want. We want to make it so that we can turn to the left or right with the one function, right? Where we don't want to have a separate function for a right turn and a separate function for a left turn. That would just be crazy, right? Especially if you were going into a competition and you wanted to show off the cool code that you did. You don't want to have a separate function for your left turn and your right turn. So here I'm going to show you how we can define a new kind of function. So we're going to write down a description of this function first. We're going to have write a function that takes an angle value. And we don't care if it is a left angle or a right angle. It just cares about the value of the angle. Then also the left and right motor speeds. So this is going to be the combination that will create your universal turning code. So here we're going to go define gyro turn. So the first thing we want to put in is the angle, then left speed, then right speed. Okay, so this is a function that's going to make it so that we don't care what angle it is, as long as it is less than 180 degrees, because we're going to turn to the left or to the right up to 180 degrees. And then we're going to set the motor speeds separately. Okay, so here we do the same thing as before, where we reset the hub yaw angle. And then we go wheels dot and then we go while hub dot motion sensor dot get your angle is less than the current angle. But here is where we're going to add some maths, because we don't want it to care if you're going to the negative side or the positive side. Because if you're going to the negative side, you're going to go negative 10, 20, 30 degrees, right? When you're going to the right, you're going positive 10, 20, 30 degrees. So we're going to work out use a new math function to turn it into the absolute value. And what absolute value does is it turns a negative number into a positive number. Okay, so if we're going negative and positive, it doesn't care if what the number is. It just takes away the minus sign if there is a minus sign, so that it always treats it as a positive number. So to do that, we go math.fabs for absolute value. If the absolute value of our yaw angle is less than the angle that was specified. So while that is true, then we go wheels dot start tank, and then we take two arguments here. So this is the left speed and the right speed. And then once we reach the angle, then we go wheels dot stop. Okay, so we go down here, get rid of our custom turn from last week. This time we're going to use a function called gyro turn. So gyro turn. So I want to change my car to turn 90 degrees to the left. So 90 degrees. I don't have to put in positive or negative. Then the left motor speed, I'm going to go at 0. The right motor speed is going to be at 20. Okay, so let's see if that works. Okay, so that's a left-hand turn. What if I want to do a right-hand turn? Then I'm going to simply change it so that instead of going 0 for my left wheel, I go 20 for my left wheel. And let's say I go minus 20 for my right wheel. And then I'm still going to turn at 90 degrees. Okay, cool. So that's just a snapshot of how maths can improve your programming. Okay, we have just used the absolute value function to make our gyro turn code a lot neater, a lot tidier, and a lot easier to manage. And I've also shown you how to use some functionality to turn Python into like a calculator, so it can do your homework for you. Okay, well, how can we find out more about the mathematical functions? How do I learn more about Python? Well, I'm going to show you this website and we can explore it a little bit more. If you want to check out more about maths and Python, then make sure you check out w3schools.org and then search for Python. And then if you scroll down the side menu, you'll see Python Math. So go into Python Math, and then you'll see all the different kinds of math functions you can use. And then down towards the end, you will actually get a math module reference that gives you all the different kinds of mathematical functions that you can use for your code to make your robot do really awesome things. Okay. I hope you enjoyed this lesson, and I will see you on the next one. Bye-bye.